Hi, good morning. Welcome to IMS 2018. I'm Razvan Rusu, Global Engineering Manager with Richardson RFPD.
Hi, I'm Jie Weng, Radio Burst Marketing Manager from Analog Devices.
We're here to introduce a new cellular infrastructure development platform for band 14 and 28 LTE that consists of a couple of key pieces here. On the left-hand side, we have the Analog Devices AD9375 development platform, and on the right-hand side, we have the Richardson-made RF front end, the D705.
So AD9375 is the industry's first wideband RF transceiver with integrated DPD algorithm. The transceiver itself supports 2T2R 1 ORX channel. The bandwidth it covers from 100 MHz RX and 250 MHz TX and ORX. And the tuning range is from 300 MHz all the way up to 6 GHz. So this transceiver also includes an ultra-low power DPD algorithm, which only consumes 1/10 of the power of the alternative DPD solution. This transceiver also reduces the FPGA cost and the complexity. AD9375 includes an ultra-low power DPD algorithm, which only consumes 1/10 of the power of alternative DPD solution. It also saves the JESD interface lanes by half, saving the FPGA complexity and cost. So the power savings, the form factor, and as well as the system cost and reduction make it an ideal solution for low power, small form factor applications such as the 3G, 4G small cell and massive MIMO.
So the D705 front-end module was designed by Richardson RFPD to deliver like a flexible platform to the cellular infrastructure users who really want to design a solution for band 14 and 28. So the board is very flexible, and just by swapping the duplexer, you can actually configure it for either band. So what we have here is a complete TX chain that consists of like 4 stages of amplification. We are delivering about 9 watts of average power with LTE 10 and 20 megahertz channels at the output of the amplifier with about 45% efficiency or better. And at the output, at the antenna port, we're actually looking at a minimum 5 watts of linear power that is actually available corrected with the AD9375 DPD. On the RX, we have like 1 stage of amplification. We have like a very low noise figure, high linearity amplifier that provides about 0.4 dB of noise figure and about 39 dBm of output IP3. The key piece with our D705 setup is the customized GUI that we develop. You have it here on the screen, that allows you to actually configure everything that is on the board, to bias the transistor the way you want, to look at currents almost in real time, and also monitor temperatures and many other things that happen on the board. The GUI has a couple of screens. The first one is the Doherty alignment chip tab, where you can actually dial in amplitude and phase values for both arms of the Doherty configuration. The next screen is looking at the transistor biasing and temperature controls. We also have like a little bit of an EEPROM memory on the board where we can actually store the configuration of the entire setup. And this tab is showing the memory page. And we also monitor everything that's happening on the UART on the last tab, as you can see. And now we're going to proceed with a live demo to show you what this entire system is capable of. We're going to run a 10 megahertz wide LTE waveform at 790 megahertz right in the middle of band 28. And then we're going to apply the AD9375 DPD to our D705 TX chain. and see what happens. So what we're going to do here, we're going to apply the 10 megahertz wide LTE signal with a peak to average ratio of 7.5 dB, and we're going to ramp up the input power so the output shows like minimum 5 watts. So now we're kind of set to about 5.3 watts. We're going to move back to the DPD GUI. And we're just going to look at a couple of things here. As you can see, the uncorrected spectrum right now for this carrier is about minus 30 dBc ACLR. We're also looking at the AM to AM and the AM to PM curves. It kind of show us that the amplifier is starting to clip. And what we're going to do now is we're going to apply the DPD correction with the AD9375 to the whole amplification chain. So as you can tell, the DPD correction allows us to pretty much gain about 25 dB of ACLR improvement. So we're down to 50 dBc minimum at 5 watts average. We're also looking at the error vector magnitude performance that actually dropped from about 10.5% to down just below 3%, which is kind of in line with the expectations for this application. For more information on the development kit or the individual pieces of the kit, please contact our engineering team or our website at www.richardsonrfpd.com
or visit analog.com/radioverse.
Thanks for watching.